Hello. Hi, Mom.
Hi.
Uh, so, this is our podcast. This is episode number 3. Our podcast name is Raw Talent, and we have invited you out here. So, if you could tell us more about yourself first.
Okay, so I have close to about 23 years of industry experience by now, and as on date, I'm working as the Chief Technology Officer of a data analytics company. And in parallel, we have another startup where we are trying to build a data aggregation and automated machine learning platform.
Mhm.
Okay. Before this, I've done my BTech and MTech in computers. I've handled a lot of positions in large organizations. I was with the Indian Army for about 20 years, and I've handled their IT systems, set up their databases at the Army headquarters level, and also been involved in designing disaster recovery solutions and business continuity plans for them.
Mhm.
So that's my background.
Okay, so let's start from the beginning. How was your experience in Army, and what was your, like you told, the basic role in your IT in Army,
Okay.
but if you can tell us more about the work that you did in Army and how is it different from what you are working on right now?
Okay. So my Army career actually started as a typical Army soldier, where I had nothing to do with technology.
Mhm.
And during the course of things, I ended up going and doing my engineering degree and then my MTech, and then landed up in an appointment where I was responsible for maintaining uh, quite a legacy application. It was actually an application built in COBOL,
Oh.
handling the entire HR aspects and database of the entire Indian Army.
Mhm.
And as we started maintaining it, we realized that at one point in time, the development of that application had come to a halt.
Mhm.
And for the last 14, 15 years, it was just being maintained.
Okay.
Uh, that's when we took up a project of trying to modernize that entire application. And that is actually where I started to get a real hang of technology and how to go about things. The volume of data was very large. The kind of hardware that we had was quite abysmal. To give you an example, we used to serve a website which used to get about 1.5 lakh clicks a day out of a Pentium 2 desktop machine. So
I had
that
Pentium in my laptop.
that was the state when we actually started working on these systems. And over a period of 3 to 4 years, we migrated the entire stack of applications. There were close to about 500 applications from COBOL and ProC. I don't know if today you guys would have heard of that language called ProC.
No.
It's essentially C embedded with SQL.
Okay.
So it's a proprietary language from Oracle. So we migrated about 200, 250 applications from COBOL and about 250 applications from ProC to Java, and a mixture of Java and ProC.
Mm-hmm.
There were certain applications which were too large for us to migrate with 5.5, 6 lakh lines of C code. So we didn't want to migrate those applications. We just created wrappers around them.
Okay.
And started to serve those same applications with a web front end in front.
Mm-hmm.
At that time, this was not a done thing. I'm talking about 2000, 2001 when JavaScript was not there, Ajax was not there. So making a call to a server, getting how a process is flowing, getting its state and sending it back to a web server was something that was not really done. Okay. And as we started working on this, we realized that there's so much happening in the technology field. So we started building web-based applications. We started moving towards Java server pages, which was the in thing in those days. And towards the end of about 2003 and 4, we started to really work on JavaScript in Ajax.
Okay. So at the beginning.
Yeah, there were no libraries then to make Ajax calls. You could make an HTTP request, have a loop which would keep checking the status of that request in the background.
Literally hard coded.
Yeah, literally hard coded. So there was no concept of promises, no concept of waiting for that request to come back. And that's how we started building our web applications. But the beauty of programming is that if you understand programming concepts, algorithms, data structures, then a language or framework or the way you code really doesn't matter. You can adapt from COBOL to terminal applications to Java applications to web-based programming fairly simply.
Exactly. So you have basically seen the start of programming till now. Like you have seen the evolution of it.
I wouldn't say that. Programming did exist before me. There was assembly level programming. There was Fortran and COBOL and Pascal based programming, and then, but typical server client programming, we were right at the starting of that.
So tell us more about what you do now and about your company and the startup.
Okay, so I've actually always been handling data more than doing programming. Even in my previous role, I was also the database administrator. We were maintaining really large data sets for the army, and we were also doing a lot of analytics around that data. There were a lot of insights we used to generate. Although we used to do that using C and other applications, we had no idea of machine learning or data science. This was not something that was really known at that time, and the reason was you didn't really have the processing power. Even though conceptually in mathematics and statistics all these concepts existed, people could run all this on a mainframe computer, but on a typical server you were really not able to run this kind of code. So it was only towards the end of my army career where we started really looking at data science and machine learning, and I started picking up that along with the other jobs that I was doing, and kind of self-taught in machine learning and AI. And after I quit the army, I actually joined this company to learn more. And here essentially what we do is we have 3 different verticals. We have a business intelligence and reporting or dashboarding vertical. We have a machine learning and AI vertical. And to support these two, you obviously need data engineering. So there is a data engineering and a technology side. We work with a host of companies in retail, e-commerce, digital marketing, media domains. And essentially we do deliver either BI or dashboarding projects or machine learning and AI kind of projects. Essentially data driven. We are not into NLP or natural language processing or making of bots, so not that kind of AI or deep learning, but supervised machine learning is where our strength lies.
So you were telling about a startup as well that you are doing.
Yes, so that is a product that we started working on essentially as an in-house tool for our data engineering teams. What we realized was 80% of the time in a data analytics project actually goes into activities which are not productive towards the end goal of your, getting an insight out of it. And they're very repetitive tasks. You have to connect to a data source, get data, transform it. So, as we were saying, 80% of the tasks actually in a data analytics projects are really repetitive in nature. So you connect to a data source, get the data, transform it, make it ready for a machine learning model to run. So it is that part that we try to automate using actually a bunch of Python scripts initially. And what we realized was this is something that every data analytics team or every company that is working on data would inevitably need. So we started to build that out as a SaaS product. It's essentially a B2B SaaS product, which started off as a data aggregation platform. Now, in a typical organization, your data could be lying in a host of cloud applications. Say, for example, if you're using Salesforce for your CRM, or you're using Zoho as a CRM, or you have some digital marketing data which is in Facebook ads or Google ads, or you may be using, say, Stripe for your e-commerce payments. So, or you may be using some kind of financial software like QuickBooks or Xero for that matter. So your data is actually strewn across all these platforms, and all of them have APIs, and you can access those APIs. But then getting the data out of those platforms, loading it into a data warehouse or a single source of truth on a regular basis without failures is a task in itself, and it needs to be done before you can actually start making sense out of all of this data. So typical processes would involve going to these dashboards, downloading this data into Excel sheets, crunching the data manually in Excel, and then using all this for insights. So our product, essentially what it does is it can connect to any cloud application which has got an API. It can also connect to all relational databases, flat file stores like Hadoop file system or an Amazon S3 or Google Cloud. Then it can connect to various email applications or Dropbox like services, and can pick up data from any of these sources on a schedule, clean that data and push it into a data warehouse. So that's essentially what it started off as a data aggregation platform alone. So once we had hold of all this data, we realized that the next logical step is to visualize it. So that's where we started to build a visualization engine, and now we have a full-fledged dashboarding and reporting engine also as a part of this entire product suite. And now we're working on building an automated machine learning platform which can take this data and actually deliver insights. So we're starting with relatively simpler use cases of regression and classification, and we intend to actually graduate to more complex use cases as we go along.
Okay. So for the people who are watching this, if you can dumb it down a bit, what is automatic machine learning or auto ML as it is called?
Okay, so a typical machine learning process involves 6 to 7 major steps. So the first step is obviously to get the data, and then you would do something called exploratory data analysis, or EDA as it is called. So the step of EDA is actually where you familiarize yourself with what the data is. For example, how many columns, what are the data types, in which column how many null values exist, how much of data is actually missing, what are there any outliers. So there are a lot of exploration around the data that is needed to be done. Now once you're familiar with the data and you understand the business problem, you would then go about doing something called feature engineering, which means creating features out of the data that you have. For example, if I have I'm looking at, say, an e-commerce store sales, and I have the date of the order.
Right.
So I can extract a lot of things out of this, whether it was a working day or a holiday, whether it was a Monday or a Sunday, what time did the order go in, was it peak working hours of say 11 a.m. or middle of the night at 12 a.m. So there's a lot of data that can come out of a single column. Now that is called feature engineering. So using existing columns, you generate a lot of other features. And those features are what actually add onto the accuracy of your machine learning model in the end. Now once you've made all these features, now there is a step of feature selection. Now you may make 50, 60, 100 such features. Not all of them will be actually relevant. And some of them may have very high degree of correlation, which means, say, you have somewhere in your data a flag called completed, and you're trying to predict how many of these tasks will get completed. So this data is actually causing data leakage. That means if this column remains in your list of data, so the neural network will or the machine learning model will immediately pick up when this column is saying completed, that means the task is actually completed.
Right.
So you have to remove these kind of columns which can cause data leakage. So you will do something called feature selection, where you will remove certain columns and you will drop certain columns which have absolutely no correlation. So there are two extremes. Either a column will be very highly correlated with the target variable that you're trying to predict or classify, or it will have no correlation. In both cases, you would not consider those columns. So you would drop these features. That's the step called feature selection. And post that, you will do something called flattening or preparation of data so that a neural network can take it. For example, if you've got, say, countries or cities, now that's typical text-based data. A neural network or a machine learning model can't take that.
Hmm.
So you have to do something called one-hot encoding, or you will convert that into some form of numerical data. So there are encoding techniques for this.
Right.
So that is the next step. Once you have this encoded data, then you will start building your model. Now that building of model itself, you understand what is the business problem, so you know, okay, I'm doing some kind of a prediction problem, and I have time series data, so you may pick up a regression model. This is again where the data analyst experience comes in.
Right.
So you'll pick up a model and you'll try to make a baseline result. If I know there is a prediction problem, I run a simple model with the default set of parameters and I get X value out of it. So now that becomes like my baseline, and which is what I now have to improve. So I will try different models with different parameters, and I'll try to arrive at what model is the best which can give me maximum accuracy. Now this is called model preparation, model tuning step. Now once this step is done, then I'll be able to deploy my model and then get predictions out of it. So this is the entire data engineering or machine learning pipeline, as it is called.
Okay.
Now automated machine learning, what it tries to do is it tries to automate majority of these steps. So most of the AutoML engines right now on the market, which includes engines like Google Cloud AutoML and Amazon SageMaker and others, they start with the step where you have prepared data available.
Right. So
essentially what they do is they'll take on from encoding of the data onwards.
Yeah, exactly.
So from features till feature selection and preparation and choosing of features is what an analyst has to do manually.
Right.
And from there onwards, what they'll do is they'll take that simple prepared data, try and run as many types of model on it as possible, pick out whatever is performing best, and give you the best performing model with the best set of hyperparameters. And that is essentially what is being called automated machine learning. Whereas what we are trying to actually achieve is to go one step beyond this and even try and automate
the
pre-processing steps in an intelligent manner.
Right.
And that is where the challenge lies.
So do you think you are taking away jobs of data analysts in that, because you are taking away the manual aspect, right?
Not necessarily, because there is a lot of value add that the data analysts can do still. There's a lot of business knowledge that is needed still.
Okay.
While we are aiming to build this in an intelligent and automated manner, we know we are at least a few years away from achieving that kind of accuracy where you can actually replace a data analyst. But for simple standard problems and use cases, yes, you can churn out solutions which in minutes, which will be equal to what and better than average data analyst would achieve in months.
Right.
So in that aspect, yes, there will be certain loss of jobs when such automated AutoML solutions come to the market. But that has been the case always. We've heard AI will start coding and they'll start generating software. We've been hearing this for years. It's not yet happened. You still find jobs for programmers. So there will jobs will still remain for data analysts. The kind of work that they'll do will probably differ. So they'll need to get involved more in the business side and try to understand that data more and try to interpret it better, ask better questions.
So
out of the data,
that
rather
ETL
than
layer we were talking about that. So an ETL layer is transforming the data according to your needs.
Yes.
As much as I understood.
Yeah.
So maybe that using that ETL layer intelligently can be a job of a data analyst.
Yes, asking the right questions first would be the biggest job that a data analyst can do. Understanding, familiarizing with both the business problem and what data is available, and then asking the right set of questions is the first job that a data analyst will need to do. Now you will realize that the skill sets that are needed for that are slightly more than what you learn in a typical 6 months data analyst machine learning course. Now there you may learn the details of 5 models or regression models and classification models and a little bit of Python and data wrangling, but you will not understand how to ask these intelligent questions. This is where experience will come in.
So suppose someone wants to go into data analyst field, like many of my friends are interested. So what would you suggest to them? Like that 6 months course is one thing, but apart from that, getting that ability to answer like ask intelligent questions and also develop in that way.
Yeah, so that will come necessarily out of industry experience firstly. So choose your internships wisely.
Right.
Choose the projects that you do wisely. Participate in as many Kaggle competitions as you can. That will teach you how to ask the right questions. There are so many data sets available, public data sets available. Take those data sets, see what can be done out of it. Don't restrict yourself to what the competition is saying. You have that data, think of what all you can do out of it. Now, that kind of habit of thinking out of the box is what will sustain you in your career as a data analyst going forward.
Right.
Not the repetitive data engineering, data management tasks which currently analysts are doing.
So, I mean, it applies to other fields as well, like not only data analysis. If you know how to think properly, how to think out of box, how to think creatively, what I would call it, that can certainly help. Like, let's move from data analyst to, let's say, web development. I'm into web development. Right?
Sure. So the same thing applies there. 10 years ago, possibly to create a chatting app like we were trying to do the other day, you would have had to write some thousands of lines of code.
Right.
Today, you can pick up a framework and do it in, say, 20 lines of code and you can have it up and running.
Right.
So it is intelligently picking up what libraries, intelligently picking up the use cases, how to optimize, how you're laying out everything, thinking about the UI UX before you start designing. There are a lot of steps that you have to follow, and that is exactly the kind of thinking that you'll have to bring now to data analytics as well. Because now you will have all these frameworks and things already ready and available. How to use them intelligently is where you start to differentiate yourself.
Right. So it's like even if there are a lot of libraries, it will still not replace anyone because you need to know how to choose a library properly. So okay, next topic. Let's talk about what you do outside of work. Let's talk about your projects, your personal projects. How do you learn new stuff? What are you learning?
One advice that I will give to anybody who is thinking of a career in IT is that you should always have at least 2 projects of your own, personal projects, always going on together, along with whatever you're doing at work.
And should it be the same field or it could be anything?
Anything. If you're passionate about that same field and you want to do it in the same field, no problems. Preferably, it should be some other field.
Right.
Even if the technology stacks are same, the implementation or the utility of that should be something different. So as long as you have these couple of side gigs and side projects going, you will remain innovative. You'll think differently. You'll know how to react to new situations quickly. It keeps you kind of on your toes also and keeps you in the habit of learning always.
So what are your 2 projects right now?
So one of my projects that I'm working on is essentially a trading platform. So what I'm trying to do is build a automated trading platform. Essentially, it is a set of Python scripts. I dumb it down to that. It's a set of Python scripts which gets all the market data, analyzes data about the stocks, tries to do a prediction of what direction the market will move in, which stocks will move up or down, and based on certain rules that I have thought of, it takes a decision to buy or sell, and then executes those decisions of buy and sell using a stockbroking API, and does the management of the portfolio, money, risk, everything on its own.
So would you call it successful?
It has been successful in the trials that I've done. I've done almost about 8 months of trial now, and I've really had very, very good results in very topsy-turvy market conditions.
So, why would you do that? Wouldn't it be risky first of all because it's your own money? Secondly, how are you trusting it to keep your money secure and keep on investing, even though we have all heard of the risks of day trading and algorithmic trading, etc.?
So algorithmic trading, firstly, just take 2 minutes to clarify some of these terminologies. Some of these terms like algo trading or algorithmic trading are kind of loosely used at times. They actually cover a broad spectrum of trading activities. Now, true algorithmic trading is something called high frequency trading.
Okay.
Now, that is essentially done by very large financial institutions and very large financial houses. And they have generally co-located servers along with the exchange. And what they are trying to do is get in and out of the stock market or out of positions in microseconds.
Okay.
Which is why it is called high frequency trading. There are a lot of orders going in at very, very short intervals, and they are trying to take advantage of the price fluctuations within those short time frames.
Right.
Now that's actually algorithmic trading as the stock exchange defines it. If you go and try and take an algorithmic trading firm license, this is what SEBI or the stock exchange describes automated trading as. What we are trying to actually do is actually do automated order processing or order placement.
Okay.
Not algorithmic trading.
Right.
Okay, so algorithmic trading essentially can be done also to do something like which we were discussing the other day, arbitrage. In one market the price is low, the same stock is being sold in the Bombay Stock Exchange and National Stock Exchange. In Bombay Stock Exchange the price is 1 rupee lower than National Stock Exchange. So I can buy here, sell here. So that is arbitrage.
Right.
So algorithmic trading is also done there. But to make money out of this, you really need very large sums of money and very large technology bases and server farms and all that. So which is not possible for an individual investor to do.
Right.
So for individual investors, what you can do is have an account with a stockbroker, log in every day, see the condition of the market, place those orders. Okay, so that is the process that we are actually trying to automate in the kind of project that I am talking about.
So day trading, we would call it?
Not even day trading, it can be at any time frame. It can be longer time frames also. That depends on the kind of rules that you set.
Okay.
For example, if I set in my application that okay, I want 1% profit, and you come out, most probably I'll hit that in a day.
Right.
But if I set it at say 15% profit, then I might not hit it in 1 day, 2 days, 3 days. It may happen over a month. So it depends on the risk reward ratios that you set.
Right.
Now coming to the second part that you were saying, how am I able to get the confidence of putting in my own money in this kind of topsy-turvy conditions? So the first aspect of investing is always doing something called risk management. And that is where I spend most of my time studying as well as developing this particular project. So the first aspect of risk management is that you diversify.
Right.
That means if I have 1 lakh rupees to invest, I don't invest 1 lakh in one share. I can invest 10,000 in 10 or 5,000 in 20 or 25,000 in 4. So I have to arrive at an optimal figure for this diversification. So that is one aspect of controlling my risk.
Okay.
Not everything will go up or down simultaneously.
It's highly probable that not everything will go down.
Yeah. And then out of these 20, I can do something called sector distribution. So
Pharma.
you have IT, pharma. In a situation like today, also pharma is still going up because usage of medicine is going up.
Right. FMCG.
Telecom is going up. FMCG is going up. Financials are down.
Yeah.
So if I diversify sector-wise, again I can control or manage the risk. And then is the absolute risk in one single position. Say I decide to go with 10 stocks, 10,000 each. Now how many do I buy? Do I put the entire 10,000, and what is the place where I say okay, I have had enough loss in this, now I need to exit? That is a condition called stop loss. I need to stop my loss at some point. So how do you figure out that stop loss? There are again mathematical formulas. I have my own formula of doing it. I don't accept more than 1% risk in any position. 1% of my total capital.
Okay.
If I have invested 1 lakh, the moment I have 1,000 loss in any stock, I will exit that.
Okay.
So that is what guards me against sudden sharp falls like the ones which happen right now due to COVID. Or when Iran oil crisis happened or the attack happened. So in those kind of days, the market will fall 4-5%. But if I have stop losses in place and my software is constantly monitoring the prices, the moment it sees that kind of a sharp drop and the price goes below my stop loss, it will exit. So that's how I'm managing the risk.
Okay.
And still, before putting in your own money, you still need to verify all this. So before I put anything on the market, I wrote a comprehensive backtesting platform for this, where I could actually test this over last 10 years, 11 years. So you can choose periods like say 2008 or 9 financial crisis, where you can simulate this kind of market conditions.
Right.
And you run this over that period, and you'll get to know whether it will actually be able to control the risk or not. So that backtesting step is really, really important.
So for someone who is starting out, if I or someone like them wants to start with this project, what are your steps that should be followed?
So obviously you need certain technical know-how, which would be related to accessing an API, placing an order on the API, getting the data from an API, storing it in a database. So assuming that you have the relevant technical skills for that, and you can do it in any language. I'm more comfortable with Python, so I did it in Python. The second step that you will need is, once you've got the stock market data, you have to decide what to buy. So you have to do something called an analysis on that data. So there are two ways in which you do analysis of stock market. There's a fundamental analysis and there's a technical analysis. Fundamental analysis essentially means analyzing the fundamental ratios and issues with the company. What is its say return on capital? What is its return on equity? What is the price to book ratio? So there are certain ratios that are very well defined, and you analyze it based on those ratios. So that's called fundamental analysis. That can also have inputs like quality of management and certain issues which are more subjective. And then is technical analysis. Technical analysis essentially means looking at the price movement and the trends. So you only have 5 inputs here. You have the price movement, open, high, low, close over whatever time period, and the volume that was traded.
Okay.
So the price and volume action is what you're trying to study, and you're trying to pick out trends in that price and volume action.
Right.
If the price is going up with very high volumes, it is likely to be a very strong upward trend.
Right.
So you would want to ride that trend. You want to buy that stock.
And if the volume
the opposite is true, if the stock is going up but the volume is low,
so
you may not want to go there, because it may be a false kind of peak, and it may just fall back again. So there are certain indicators like this. There are a lot of mathematical indicators. There are certain libraries which can calculate these indicators for you. So using those rules, you essentially define your own strategies.
Okay.
If so and so indicator is beyond this value, I will buy.
Right.
These are the kind of strategies that you write. Okay. You can have one strategy, you can have multiple strategies, you can have a polling of strategies, which is what I follow. I have about 7 different strategies that I've backtested over long periods, and I take a kind of a poll from all these 7. As long as 5 out of these 7 strategies are telling me buy or sell, I would take that decision. So that depends on you how you want to implement it, and definitely my advice would be backtest all this as thoroughly as possible. Spend some months on backtesting all this. Test it over different kind of stocks in different kind of market conditions for different lengths of time.
Right.
Okay, and then whatever is your best performing strategies or set of strategies, you use that to decide.
Okay, and then just place an order with the API.
Then place an order with the API. So the kind of reading or knowledge that you will need is 2 kinds. One is the technical knowledge, and the other is knowledge of financial markets. So I would recommend a starter or a newbie to first start reading about what stocks in markets are, how they behave, what is the role of exchanges. Then read a little bit about fundamental analysis just for your knowledge, so that you can follow the current news cycle and financial news and financial newspapers. Then concentrate more on the technical analysis part. Understand the role of these indicators, understand how to identify these trends, how to read a chart, look at candlestick patterns on a chart. Once you are able to do all of this, then you can actually sit down and start writing something like this particular project. So if you see the entire life cycle of something like this, it will be nothing less than about a year's work for you to, and a year is a very good duration for a side project.
Yeah. So you're saying that we should have longer side projects.
Yes.
An year-based, not
So
small
there will
projects
be
like
smaller,
a tic-tac-toe.
so there will be smaller milestones within this. Now, if you have to build something like this, you will first sit down and you just write one piece of code which will fetch the data from API and store it.
Yeah.
Now that can become a mini milestone for you. It will teach you a certain set of skills, and you keep that code aside to plug it into your larger project. Then you can say, look at calculating these technical indicators. That can be a project in itself. Writing the backtesting platform. So there will be smaller projects or smaller milestones along the way. But manage your side projects like projects are managed professionally in organizations.
So coming to that,
keep milestones and
coming to that, how are professionally, like how does an industry work? Like when you, like in the college, you don't get to know what you will be doing really outside in the industry. So when you go out in the industry, when a fresher goes out in the industry, he might face a lot of problems. Like he wouldn't understand the CI/CD pipeline. He wouldn't understand the testing.
Yeah.
So what would you recommend? How to get started on that and how to get an experience for that?
So the best thing to do this is actually, again, like I said, choose your internships wisely. Choose internships where you get maximum exposure. That is your first step. And even within your college projects, don't look at college projects to be successful. That's not their aim.
Right.
College projects are meant to fail. They should fail. But they should give you at least 100 lessons in that failure. So try and, even if they take longer, try and manage those projects like an industry project would be managed. If you start with test-driven development during your college, whenever you hit the industry outside, you'll already be familiar with what TDD is. So you'll be in habit of writing tests. So getting those good habits in place is what is important. So use your college time, college projects to get those habits in place. Don't look at completing the projects. That shouldn't be the aim.
Right. So suppose I have a project in mind and it requires some skills that I currently do not possess, and I think it is very tough. So for example, I want to make a bot that automatically edits my videos, for example.
Yeah.
And so for that, I need knowledge of maybe a lower level language to make it faster, like C++, like Golang, like Java. And I would need the knowledge also of having video knowledge, how it is encoded, how it is decoded, etc. Or like when we were discussing how to do end-to-end encryption for an audio, for a video. So how would you suggest someone goes and learns those things? Because it's quite intimidating to anyone that I would have to code in C++, so it's a bit tough. It's not that easy as Python. Python is easy. So
one thing is, with today's day and age and the kind of resources you guys have at your fingertips, this actually shouldn't come up as an issue as to where you go and learn, because there are infinite possibilities for where you can go and learn. The aspect of what to learn and whether that will be intimidating or not. If you use your initial years of college wisely and shore up on your fundamentals, then whether it is C++ or JavaScript or any other programming language, it won't really bother you. If you are sure about programming logic, if you know how to solve a problem using algorithm and logic, then whether that logic is written in Pascal or Fortran or C or Java, it won't really matter. So first thing that you need to get imbibed in your heads is that languages don't matter. Now every language has certain good points, certain capabilities, certain shortcomings. So some things may take longer to do in certain language, it may be shorter in some other language, but anything that can be put down in pseudocode can be programmed with any programming language.
Okay.
Yeah.
So that's because I have gotten questions from like my juniors that the problem they face is like they actually get intimidated by languages. So that's the thing.
The ability to think in pseudocode is what you need to get. And whenever we actually start our computer science journeys, wherever, so first thing we are taught is that flowcharts and actual pseudocode.
Yeah.
Now, as long as you retain the ability to think like that, think in pseudocode first before you start writing actual code. Then you will no longer be intimidated of languages. Because in pseudocode, if you figured out how to solve it, then implementing it is just a Google search away.
Right.
How to write this particular loop in C++, you can just Google that. As long as you know what to do in that loop.
Okay.
So that is one part. The other is something called design patterns.
Right.
Okay, so one is the algorithms and data structures. That's the basic building block. And then how to put them together in design patterns. So knowledge of design patterns, trying to use those design patterns as early as possible in your projects is also important.
Okay.
Say a simple application if you're building, you can actually make make do without breaking it into 10 modules. But if you follow a standard design model, if you follow an MVC pattern, or if you follow a standard design pattern in say Python also, if you follow an object-oriented pattern, instead of putting everything in one .py file, that will become your coding style.
Right.
Okay, so thinking in pseudocode, knowledge of design patterns, these two things will make sure that you are no longer afraid of any language.
Right. So, so next thing is, what is your preferred tech stack as of now? What's the most used tech
my
stack?
preferred tech stack changes almost every 6 months. But as on today, I am working with Python, Flask, Django. And on the machine learning side, I'm tending towards scikit-learn. And we're actually, since we're working on automated machine learning, so we're using scikit-learn pipelines to automate the entire process. I personally don't really like to use Jupyter notebooks.
Okay.
So I do my Python coding outside of Jupyter notebooks and the Anaconda environment. I work primarily on Linux, although for work you still have to boot into Windows. But that's more of a painful experience than anything else.
Right. So as you said, your tech stack changes constantly, and that's the thing that I want to tell to everyone also, that don't stick to one tech stack. Like people do Mern and they then stick to Mern stack, and then they don't develop the habit of learning more things.
So I have done, as I said, we started off doing COBOL programming and then moved to Java, then to JSP, then to Spring and Hibernate frameworks. Then we came to PHP. So done programming in every PHP framework possible. Then came to JavaScript and did Node and JavaScript. Python has been continuous throughout. Within Python, both Django, Flask, and then now machine learning side. So as long as you have a breadth of this tech stack with you, you'll be able to solve any kind of problems. Try and broaden your tech stack as much as possible.
So, lastly, the few things. First of all, wanted to know more about your job as a CTO at a company, and what does your day look like as a CTO, and do you get to learn more things while in your job, or do you do it in your side projects?
Yeah, so both. I do learn in my side projects, and that's my primary source of learning. But I tend to choose my side projects also in a manner that it kind of gels with my job a little. So since as you go senior in your roles, you have to shoulder other kind of responsibilities more than just learning the technology side of things. But as a CTO also, I tend to be hands-on. I still like to code, and I still work at least in the initial POC stage. I would do the POCs myself and try and first flesh out the architecture of a product before I give it to the dev team to actually start working on it. And then a major share of my time goes into taking architectural decisions. What tech stack to use, how to deploy it, what design pattern to use, whether to, at what stage do we start testing, how do I set up the deployment pipeline, where to deploy, what kind of resources, what kind of machines, what hardware, sizing of those machines, monitoring our servers. So there's a whole host of activities which you can classify as development and ops. So as the CTO, both these verticals fall under me, as also actual customer delivery.
Right.
So there are always client engagements that are on because we have a services business and a product development business. So there are two separate sides to it. And the services business, there is always constant client engagement and delivery to clients.
Right.
So doing kind of a oversight on what is going out. And then there is always new business development, speaking to new clients, proposing new solutions, architecting new solutions for them.
Right.
That's another aspect of the job, and which is something that I really love doing.
That's amazing. And so you work at, should I call it a startup as of now?
It is a startup,
it is
definitely. It's a very small company that way. We are just a 60-member team.
And what do you think is the difference between working in a startup or working in a big company like big 5 companies, Google, Amazon, Microsoft?
So the biggest advantage in a startup is that you'll have a host of things that you would do. There are no kind of rigid enclosures or boundaries, and the pace of work is really fast.
Right.
There's very little bureaucratic red tape, so decisions will come a lot faster. There's a lot of flexibility to what you want to do and how you want to do it. There's less legacy baggage. And when I say legacy baggage, it means if you have something which is already running and there are a billion people using it, you can't just go and make changes to it. So at times you may find that something is so clunky. For example, Amazon interface. Now it's really clunky compared to a lot of really good e-commerce platforms that you have now. But Amazon really can't go and take sudden decisions and change their technology stack or change the way their store front works. So you have a lot of legacy baggage in large companies. And at a starter level or at a level where you're going in and joining in as a fresher, there are a lot of learning opportunities there if you are in that kind of a bracket where you're sent on courses, sent on these things. But for the majority of people, the learning really stops when you join these places. They have so-called training programs and everything else, but the kind of learning that you get in a startup will be very different. There won't be rigid enclosures or verticals in which you'll work. As a developer, you will have to set up your own machine on the cloud. You have to, you'll be doing kind of entire DevOps yourself. You may be writing your tests, you may be executing those tests, you may be doing data validation also, you may be creating your stories on the Scrum board. So you'll be doing the entire breadth and width of activities yourself. That's the biggest advantage of working in a startup. Disadvantage, if you don't have a very good set of people mentoring you, you may pick up a lot of bad habits. So in large organizations, the procedures are well set. Rules are very well set, but they are set because of a reason. They work. That's why they've been set. So you'll pick up a lot of good habits there.
So you told to choose your internships wisely. How do we go about that? How do we choose?
I would recommend if you have, on an average, you would do about 3 internships during your engineering. Maybe say a 1 or 2 month internship, then a 2 or 3 months internship, and a 6 months internship. I would recommend doing this, at least 2 of them with a startup or a small size company, and 1 of them with a large company. Get an exposure to both. Not everybody fits in a startup kind of environment, not everybody fits in that environment. Try and learn as much as possible. Don't try and forecast that this is what I like. You really don't know what you like right now. Because say if you imagine that you like working on say full stack development, and you go and join somewhere as a full stack developer, and after 1 year you realize there is no growth here. I don't like this. Have options, try out different things. So if in one internship you've gone and worked on a machine learning project, in the second one go and work on blockchain, and the third one go and work on web development, get an idea of what the industry is in different organizations, possibly different industry verticals.
Okay, and how to choose a company? Like, how do we know if we'll have good mentors out there or not?
Speak to people, find out, look at their LinkedIn profiles, check out their GitHub repositories. if there is a person who does all these side projects, he'll have this thing. So unless a person is active outside of his office, he won't be a good mentor.
Right.
Personality wise also, you'll get to identify good programmers very easily. They're very easy to spot in the group also.
Yeah. So what do you think? Does college placements is a good option for this, or do you think we should do our own research and then choose our own company?
Both. Depends on the college firstly, but both. If you get a good company out of college placements, why not? Constantly reach out, network to people, speak to people in the industry. When you go on hackathons, you connect with people, maintain and touch with them. Keep in touch with your seniors. They would have gone and joined 20 different companies. So get to know what is the work environment there, and then make informed, intelligent choices. And don't let CTC or the money or salary be a factor in the initial years. Unless it is a compulsion of some kind, don't let that be a factor.
Okay. And some financial advice as well, like as you are doing some financial also.
Yeah,
so
I wish somebody had given me that advice when I was your age.
So if we start in a company, how should we manage our expenses? Like right now we are very young, we don't have as such of responsibilities, we don't have expenses.
So save as much as you can, but again, live your life. So it's important to remain balanced. You do need to save intelligently, so save as much as possible, but also enjoy your life. I mean, this age also won't come back again. So as long as you can maintain that work-life balance, and you are in habit of doing that since your college days, it will possibly sustain you through your career as well. But make intelligent financial decisions as early as possible. Start saving, start investing as early as possible. Set aside 15, 20, 30% of your earnings, whatever they are, for purely investment purposes. When you're young, you can invest with a long-term horizon, and in aggressive instruments, you can afford to take more risk. You don't really have commitments coming up, so choose higher risk investments with longer time horizons. Study the power of compounding, and make use of compounding. The biggest advantage you have when you're starting early is that you can really compound money. Even if you start with a small amount, you can really turn it into a very large chunk of money by the time you think of retiring, or you really have some responsibilities for which you require money. You could use the power of compounding. Try a simple exercise. Take an Excel sheet and just make sure that, okay, if you have a sum of 1 lakh rupees and you can earn 300 rupees out of it in a day, what is the percentage?
In a day?
Percentage 300 is 0.03. So 0.03% return is one can expect to make without taking too much of risks. So if you can do consistently, you can get this kind of returns, and you keep adding this money without spending it to your base capital. See what the amount becomes after say 5 years or 10 years, then see what it becomes after 20 years.
So I saw somewhere, like if you save around 10,000 every month, let's say 10,000 or 5,000, after like 20 years, I guess it turns into almost 6 to 8 crores. And that's the power of compounding.
That's the power of compounding. So utilize that. You have that advantage with you. But don't let this determine the career of path that you will take. You have money is important, right? But quality of life is equally important. So concentrate on that as well.
Okay. So you were our oldest guest in the podcast series. Everyone was a bit younger, who had some experience, but you had a host of experiences. And I hope it was informative to everyone who was watching. It was very informative to me, and I hope you also enjoyed being
Definitely.
here. Definitely. And giving such advices to people in our college is really important, because everyone is going after just doing 2 months courses and then getting a job and then just sticking to that life. And I think we need to change that a bit. We need to have some open source culture. We need to have some projects, some coding practices, and for that we started this.
Yeah, so take a look at what the best universities in the world do and try and emulate what an MIT would do. We have better people, better talent than what you'd find at MIT. It's just that their output looks a lot better because they have better avenues and facilities. Talent wise or capability wise, I'm pretty sure our universities are at par, if not better than them.
Okay, thank you.
Thanks.
Thank you.